So good morning, everyone. So this is my paper with Alex about risk sharing within Brazil and the Mercosur countries. So I'll begin discussing briefly what is the idea behind risk sharing, which is basically reducing your consumption volatility. You basically want to share what is your idiosyncratic shocks. So the international business cycle theory points to a sizable welfare benefits from risk sharing and the reduction of consumption volatility. So that's why we want to reduce consumption volatility, of course, thinking about welfare gains. So the main idea is that you want to generate income flows that is unrelated to your personal income. So the first question that pops up is, what level of consumption smoothing is actually achieved and how can it be improved? Because we have this idea of, and the models of perfect risk sharing. It's exactly what I say in the beginning. You're sharing out your idiosyncratic shocks. You're only exposed to aggregate shocks because you don't have anyone to share your aggregate shocks with. So this first question is how much are being achieved and how close are we to this perfect risk sharing scheme? So first, I'll talk about the role of financial markets. They are one of the main drivers of risk sharing with this idea of cross-border holding of assets. So you basically want to hold assets from other countries or regions. Again, this idea of being unrelated to your personal or regional income. So we have this importance of finance integration. So we expect the more integrated you are, the more risk you share. But actually in literature, you have mixed evidence because some authors argue that if you have a highly integrated financial markets, you tend to amplify your financial and macroeconomic contagion. So anyway, finance integration is important for risk sharing, but we also have another channel that's important. It is fiscal federalism. So this is the idea of a public mechanism providing risk sharing. So basically the government to have a role now. It can tax regions that are above income and transfer to regions that are not well. So, and another importance of fiscal federalism, of the role of governments, that not all the agents could have access to financial and capital markets. So the government could act improving welfare. And actually this is important. For example, during the creation of the European Union, they're looking at the United States system to see what they could achieve with a central government with this power to transfer funds. So why is the regional case important? Because yeah, we look at the regional case just because first these models, they began at household level, then they evolved to the international macro literature. But because international integration is limited, because you have limiting factors like political differences, taxes, transaction costs, cultural differences, and etc. We started to look at the regional level, and the evidence was that across countries the risk sharing was way far from perfect. So we have this question: are the less amount of barriers you have within a country, do they result in higher risk sharing? So we could look at this literature at a regional level and just maybe use it as a benchmark for international integration. And you could also ask, what is being actually achieved by the central government? So what we try to do in this paper, what I do is we get this vast literature and try to apply it to Brazil, because at the regional level, there's not much done within Brazil. So our main contribution is just try to build some data, to get some data and just estimate those models and try to just check for this within Brazil. We also estimate the models for Brazil in relation to its neighbors in Mercosul, trying to compare the results and see if you get what is expected by the theories that have higher integration inside the country in comparison to international level. And we also estimate how much of this risk sharing within the country is achieved by the fiscal federalism, or about the tax and transfer system within Brazil. So we follow two models, two different approaches. The first one is to estimate the overall degree of risk sharing. So we follow this model from Crosini, and then we proceed with this model from Azurbalyakin, which is a modification of Crosini's model, but they are quite similar. So we use them to estimate the overall degree of risk sharing, and then we proceed with a second. It's a very simple model, but it allows us to use the taxes and transfers data to see how much of what fraction of income shocks are smoothed by the federal government. So, okay, first I will discuss briefly about our data. So everything is monthly here. We turned into yearly. We work out with per capita terms, in real terms. So, okay, that's our data. And okay, I'll talk about the first model we use. So use this Crosini specification. It basically consists on an income pool model. In a particular region, it sells a fraction of its income, and in exchange, it gets a claim to a pooled income stream of all the other regions or countries. So this model assumed that the permanent income hypothesis is valid. So there is perfect temporal, intertemporal smoothing, and each agent only consumes out of their permanent income. So that we will change that on as the value model. So we allow agents to consume both from permanent and from current income. So when you combine the pooling equation, it's basically a share of your own income and a share of the aggregate income to the permanent income hypothesis, we get the main equation of our model. So we just get the idea, lambda J is the risk sharing parameter, CJT is the region or country current consumption, CAT is the aggregate to take the simple average of the of consumption growth across all the regions, and this other term YPJT is the permanent income, which is calculated on this way. I'll give more details on next slide. How do we compute this term? So if you look at this equation 1, it gets the main idea of risk sharing. If supposing you are in a situation of full risk sharing, so this lambda J will be 1, which means that your consumption, it will grow exactly as the same as the average consumption growth, meaning that your consumption is just following the aggregate. You are not exposed to any idiosyncratic shocks. So you just don't follow your permanent income, just aggregate consumption. And in the other situation would be this being 0, lambda J being 0, so you don't share any risks. You see an increase in your permanent income, you increase your consumption. So how do we proceed with the estimation of this equation? So we need to compute permanent income. How do we do it? We assume a process for income growth, and then assuming process, you can use this equation 2 and compute this term and proceed with the estimation. So we follow Crucini, he assumes a white noise process for income growth. When the growth rate of income follows a white noise process, this term will just become the first difference of income. And for robustness, we also assume that the income growth will follow on our autoregressive one process and also a joint var one with the aggregate income. So when you assume on ARMA process, this equation here is very helpful to compute the permanent income update, which is this term. And for the var1 process, is a bit more complicated. It's similar to this, but it involves matrix algebra. But you just have ways to estimate those processes, get the coefficients, and calculate this term, and then use them to estimate this equation. So the next model is still the same category of model, but it just now relaxed this hypothesis of, the hypothesis of the permanent income hypothesis. So now agents could consume out of their current and permanent income. So when you combine those rules, you get this equation. It's similar to this equation 1, with the difference is that now you have current income here, and your permanent income here is left to the error term. So this is relevant, relaxing this assumption, because you, at least in Brazil, you can assume that all the agents do perfect intertemporal smoothing. So there is a considerable degree of rule of thumb agents in Brazil. You can also interpret these coefficients as the degree of rule of thumb agents in Brazil. So you could also notice that this equation is a special case. The equation 1 is a special case of 4. So when you assume this coefficient is 1, you have perfect intertemporal smoothing. So current income is just disappear, and this will become your updated permanent income. So the equations are very similar. What is different then will be the way you estimate them. So as is left for the error term, use an IV approach, use the first and second legs of the model variables and instruments. So now let's proceed to the results. So for equation 1, so we first estimated the process and computed the permanent income terms. I'm not plotting them here, it's because I don't have much time, but basically found that a risk sharing degree of around 0.6% within the country. When you assume a vector autoregressive 1 for the income process, it's a bit higher. But when you estimated those income process, most of the coefficients, they are not significant. So we could assume that a random walk specification is the preferable one. So within the country, found that around 86% of integration, and this is not statistically equal to 1, which means it don't have perfect risk sharing. But when you estimate that for Mercosul, the results are way lower. They are more sensible to our income specification, but they are still lower than what you found for the regional level. So this is evidence that integration is much higher within the country when you in comparison to Brazil within its Mercosur neighbors. So you have some scope to improve welfare, just trying to share the aggregate risk within Brazil with its neighbors. So here is the instrumental variable estimation. Now we assume this equation. The difference now is that you don't have the restriction of the coefficients must sum to 1. And now I'm using an instrumental variable approach. This is using one leg of all the variables as an instrument, is 1 and 2 legs as instruments, and no instruments. So I got very similar results for the states, for the regional level, something around 83%. So we proceeded with the Hausmann tests just to check the consistency of the estimator. It suggests that the estimation with no instruments was the preferable. And however, when you estimate them for Brazil within Mercosur, they got even lower and even statistically equal to 0. So what you could get from evidence of those models is that there's a much higher integration inside the country as expected. In our second model, which tackles the problem of fiscal federalism, we just use this model from Salah-Martin sites. It's very simple. We just begin with this this equation for disposable income. It's basically your income plus what you get from transfers from the government minus what you pay on taxes. So you can rewrite this equation using defining elasticities of taxes in relation to income and transfers in relation to income. And then we could just call it omega. The interpretation of this is how much of a shock or the growth rate of your current income is translated to your disposable income. And you can think about 1 minus omega of what the percentage of shocks that are smoothed by the federal government. So then we estimate those equations. One thing for taxes, it was very easy to get the data, but for transfers, I got all the transfers the central government made to the state level government. And I summed to all the transfers the central government made to all the city level governments, which means like all the resources that were sent to the state, both to state and city level governments. So, okay, we estimate those elasticities here, then to estimate omega using both those two equations. So we both estimate them both by OLS and by instrumental variables, just because it could have simultaneity bias on those equations. So that's the first results we got. We also follow the suggestion post on this paper. They did basically the same thing, but this paper is from 2003, so just updated the results, and they suggest that you should assume fixed effect model for the transfers equation, just in order to capture this redistributive role of the tax transfer system. So if you look at those values, you have evidence of that net transfers are counter-cyclical, just because when you have an increase on taxes, you have those elasticities. So when you have an increase in income, your taxes increase. When you have an increase on income, your transfers decrease, so they're counter-cyclical. And this table here is just, this beta is the same as I plotted here, but those are the fixed effects that I found for each state. And you got an interesting but expected result if you see states like Rio Grande do Sul, São Paulo, Paraná, they're all negative, which means that transfers would be always smaller to those countries. What I mean is they're not responding to, this term is not responding to income. So, and if you see other states like Acre, Amapá, it is positive. This is evidence of the redistributive role of federal government. And here is the calculation of omega, just using this equation here. So we can calculate this for each state, and here is the average. So what we found is that taxes have the taxing system have a higher impact on income on risk sharing than the transfers. And it's around 12%, 14% here, and it's higher for richer states. So that's the point. If you base on the IV estimations, 1 minus this is 14.4%. So our estimation says fiscal federalism reduces impacts of shocks on state products on around 14.5%. So they also suggest these effects are higher on wealthier states. Of course, this is a result just because use those equations here, and the level of taxes and transfers are higher to richer states. So you could expect having higher values here. And okay, most of the volatility reduction comes from taxation, because here is how much of the reduction comes from taxes and how much comes from transfers. Again, it's also results that comes from the higher level inflows of taxes than you have of transfers. And this is a clear evidence of the redistributive role of the central government. So what you found is that there's a high degree of risk sharing within Brazilian states, around 85%. The role of the central government is significant. They reduce around 14.5% of the idiosyncratic shocks. So you could say that its main focus is income redistribution and not risk reduction. But however, the degree of income smoothing within the country is high. However, the degree of income smoothing in the country is high, but we found evidence of a much lower degree of risk sharing among Mercosur countries. So it suggests the possibility of welfare gains focusing on sharing risk with our Mercosur neighbors. And a future research subject that a question that I'm trying to answer now with Alex is basically want to measure the effects of borders and geographical distance on risk sharing. And here are the references. So, okay, I was quite fast. So, do you have any questions?
No chat não há nenhuma pergunta. Alguém tem alguma pergunta para fazer, o Eduardo?
So, Eduardo, perhaps you can use this time to describe a little bit more the database.
All right.
I think that, yeah.
So, okay. The first thing I want to say, the reason this literature wasn't much explored on the Brazilian regional level was the lack of data. So as a gross trade product, I got from IBGE, the regional accounting system. So they provide this gross state product, and we also have price indexes there. So I got the population also from IBGE, and in this product and state price, this product data, could also be found as indexes, and work it out with indexes in this in those first models. So what I did is transforming the population in an index. Just I could take these variables into per capita terms. So
yeah, so
Texas,
can I
yes,
just jump in? Yeah, I mean, what I meant is that to give sort of a very brief description about exactly how we started the importance of the Brazilian case, because these sort of risk sharing tests have been extensively done in the international macro literature. So many authors, as Eduardo pointed out, Crusini, Winkup, you know, there's a huge amount of tests for countries testing the degree of risk sharing, and also for individuals within a country. But there is less studies, and in fact, in the case of Brazil, as far as we are concerned, there is none testing the degree of integration or this sort of risk sharing models for states. So the main innovation of this paper is to do this test for Brazilian states. And obviously the main difficulty was to build this database. That's why I just wanted to stress that point out.
So, Cesar?
It's not a question, but more of a suggestion, I guess. You know, it's interesting that the thing was done for Brazil because we are Brazilian. But what if you could compare that with other countries and try to get a sense of, like, tell us a little bit about, so for instance, say you do the exact same thing for the US, then what kind of thing do you get? You know, what are the, I'm not talking about, you know, within countries, I'm talking about the state. It's like, what is, if you look at another country and the interstate risk sharing, what is special about Brazil versus the other country? Is it more or less? Is the government doing more or less, given, it's like, okay, you got that for Brazil, but is Brazil special? Is Brazil more of the same? Just a suggestion.
Yeah. Would you like to answer that, Eduardo? Or?
I think you can answer that. I think, yeah, the results actually they're quite similar to what Crusini found from the US, but I actually don't know what is special in Brazil, if there is something special or if that's more the same.
Well, okay. I think one very important result from this test is the following. Although it's similar in a sense with what Crusini found for the United States, Brazil has, when we did Brazil, we also treated the Mercosur countries as sort of states, okay? So what we found is that there is sort of a border effect, which is irrespective of the geographical difference, which this is not done in that case. So we find that the risk sharing within Brazilian states is higher than a risk sharing between Brazilian states and the other states of Mercosur. So showing that these, you have, obviously you have more integration in Brazil because probably you have an economic integration with Mercosur, but you also have cultural ties inside Brazil, maybe the transport infrastructure. So other factors can explain this higher degree of risk sharing within Brazilian states rather than Brazilian states and the Mercosur. But thank you. I think it's a very important thing to do. We do it in the paper, but maybe we should stress that a little bit better. I guess
Thanks for the suggestion.
I guess we're short of time, but we can take another very quick question if.
Yes.
I was going to follow on the question if there is any chance of state-specific policies being impacting the differences for the VAT estimation across the states or not. would expect that or not? Because I'm thinking quite often that you guys get results that are close to the US.
Yeah.
Sharing at the state level. Could that be something associated with the data that is considered everyone the same in each state in that direction?
So Eduardo, are you going to answer or shall I?
No answer.
Yeah. Gary, go on, go on.
I'm sorry, do you mind repeating the question?
It was.
Do you mind?
The first one was like, if state-specific policies could play a role in these consumptions moving inside that state. And also that called my attention because you mentioned that the results are resemble those of scrutiny for the United States, what is surprising in some sense. So what could be playing that role for this result?
Maybe we actually run all these equations, like this table here is a panel, but it also runs state by state. And the richest state got even higher coefficients. But
I think it is interesting, the question, because even if you get consumption regressions, there is even when Campbell and Mankel did their tests in the 80s, you find for example, a degree of rule of thumb consumers in the US that is close to 50%. And you find something not very dissimilar here in Brazil. So, yeah, I mean, specific policies that are specific to states would definitely explain different degrees of risk sharing between states and the aggregate, in the case of Brazil, and we obviously have that in our results, okay? But your question is in fact interesting, because we can't explain the similarities between the degree of risk sharing between Brazilian states and the aggregate vis-a-vis the US, okay? So yeah, that is interesting. We need to maybe come up with an explanation why quantitatively it's similar. If, for example, when you do the test for the consumption regression and you find, let's say that there are 50% of consumers that are non-Ricardians, then you have a sort of explanation. Okay, people don't have access to credit and stuff like that. But in the case of, in average, finding similar coefficients for risk sharing between these two different examples, it is an interesting finding. It could be due to the fact that it's two federal countries, right? That have a high degree of integration, share the same language, share cultural, their cultural ties, their transport systems that are infrastructure inside that is better than out the border. So those could be factors, but we don't take a stand on that, but I think you're right that we maybe need to think more about that comparison of the results. So thank you for the questions.
Okay. So let's move on.
Okay, thank you.
Yeah.
Yeah.
Dá para ver legal? Okay, so I'm going to present this work, which is co-authored with Philip Kircher, Luis Brotherhood, and Michel Turtilt, the economic model of the COVID-19 pandemic in young and old agents, behavior testing and policies. Caution, we are changing everything as we speak, but the results are interesting nonetheless. So everyone knows COVID-19 is a global pandemic. So it looks like an aggregate shock, but there's a lot of like idiosyncratic things going on, in particular regarding age. So there are age-specific things like death rates that change a lot across age groups, but also, as we'll see, behavior changes a lot, and externality imposed by the different groups, and maybe the policy impact. Another thing is that testing seems to work a lot because there's a lot of people that don't know their infection status. So we want to tackle that as well. And a lot of the discussion about policy with COVID was related to lockdowns, like let's put people at home, but do people change their behavior on their own, even without policy? I mean, if the world is risky, do people change their behavior? So what we're going to have here, as the title alluded to, is an economic model. So we're going to have choices. People are making choices, and they're going to be a little bit uncertain, so we can make testing interesting. So it's an equilibrium model, okay, with behavior, incomplete information, and age. I think we're going to learn a bit from the benchmark, in particular that the behavioral change is substantial, especially among the old, who are more likely to be affected by the pandemic. And also there's an intricate externality that that pops up once you look at these different agents. In particular, it will be a great idea for me if everyone went outside. I stayed at home, people got infected all over the place, and we reach herd immunity. By the time I get out of home, the world is safe again. So there's like this interesting externality. There's also a negative externality that when people go outside, they usually worry about the fact that they might get infected, but not so much as the fact that they infect others. So there's like a negative externality of my behavior, but there's also a positive externality that if I get infected, I'll make the world better for other people. All right, I will very quickly talk about what happens with lockdowns in our model. Mild lockdowns can actually backfire and lead to more deaths. I'll explain that in a bit. Stronger lockdowns for everybody, they work if they're very long until a cure or vaccine comes along. And one policy that was very talked about was targeted lockdowns. If the old are more likely to die from the disease, let's lock them down and let the young roam around. Actually, this saves lives, but decreases the old agents' utility. So like, since remember, there's behavioral choice here. So they take care of themselves. So if you lock them down more, they don't like that. Very much work in progress is optimal lockdown. I'll talk about that. So it's a mild lockdown that lasts a long time and actually targets mostly the young, not the old. So that may be a little bit counterintuitive. I'll explain that. We also, again, we talk about testing and because people are uncertain. Since we have different groups, we might also think about separating activities, like, you know, set aside some hours in which only the old can shop in supermarkets, for example. That actually helps a bit. Now, we're going to have behavioral change. Do people change their behavior? Yes, they do. Here's some data separating those above 65, which we're going to call old in our model, and those younger than that. And then as the pandemic starts to take place, you see people, lower numbers here is more social distancing. So you see people socially distancing, but you see the old reacting more. We're going to see that happening in the model as well. Okay, literature, I don't have time for this. I just want to tell you that there are tons of papers. And if you look at all of this, there's a ... at the end. Like, there has never been one single topic for which economists have devoted so much time as COVID, ever. But there was stuff coming on before that. And the thing that, you know, economists are good at is to talk about behavior, right? So there's this very important paper by Kramer, the Nobel Prize winning economist that got for randomized controlled trials, but that has nothing to do with randomized controlled trials, which is how to integrate behavior in epidemiological models. So there's a lot of, not a lot, of theoretical work and very, very little quantitative work. So I've worked on some of these co-authors before. There's a couple of others, but not much. Anyway, let's keep going. So let me jump into the model. So the models in discrete time have different ages, young and old. And I'm going to denote the health status of these people by J. So we're going to have healthy guys. So the usual guys that you see in these models are the healthy guys, the infected guys, and the recovered guys. So you're healthy, you may get infected, and you may recover. So we're adding two other guys here. So we're adding these quote unquote fever guys. So these are the guys that might feel something, but they're unsure whether they have COVID or some common cold. So these are the guys that would be valuable to test. So everyone that is healthy, before they, once they get infected, they spend some time as an unsure fever guy. Some of the infected guy can recover, but others may develop some serious symptoms. Think about people that need to go to the ICU in the hospital, ventilators, things like that. So I'm gonna call these guys symptoms. Think about serious symptoms, not like some mild coughing. These guys can also recover, but may also die. Those that do recover become immune forever. We have absolutely no idea if that's true for COVID or not, but that's our assumption. Then we're going to test some people. There's going to be a testing probability C, underline P. P here is for policy. So this is something that we're going to play around. We're going to test more, less people based on changing this guy. And the death probability, delta, depends on the availability of hospital beds. So if we have 10 hospital beds, but 12 patients, 2 are going to die for sure. That's what's going to happen. And all of these probabilities are dependent on age, okay? So the death, the recovery probabilities, the death probabilities for the old are always worse than for the young based on data. So what do people do? They have some time that they have to devote for a few different activities. They can work and they can have some leisure outside or leisure at home. So think about, so working here, so what we are running absolutely right now, remember the work in progress, is the ability of you to work from home. Okay, we already have results from that, but I'm not gonna show you today. Think about this work actually going outside to work, okay? Leisure outside is going to a bar. These are the hours you spend at a bar. Leisure at home is Netflix. And it adds up to 1. Now, when you go to a bar, the amount of goods that you get from going outside is a mixture of this X and the time you spend outside. So L is the time you spend at the bar. X is the amount of beers you get at the bar. So you don't get utility if you go to a bar and don't drink beer. But you also don't get utility if you buy beers but don't spend any time at the bar. Okay, so it's a composite good. And here are your preferences. You have utility from consumption. These are consumptions that you don't have to go to the bar. So this could be consumption out of food you eat at home. Utility from these goods that you consume outside. Forget about the orange stuff for now. Utility from staying at home leisure, Netflix. Okay, and B here, B is the utility that you get from just being alive. Okay, so we're going to normalize the utility from death to 0. So there's got to be a reason why people want to be alive. That's given by this B. Now, what is the lambda guys here? So focus on the first one first. So this lambda J here, if you are, so think about, you are infected and you know that you're infected. If there's the end of the story, you're going to throw a party with a lot of people outside, okay? Because you cannot get infected twice. So in order to avoid this, we have this lambda J guy here. So if you are sick, you have some altruism. This lambda is positive. So that increases your utility of staying at home watching Netflix. So you're altruistic towards others. And the way we're going to generate lockdowns in this model is, look at this P, look at this P again here. So remember, P is policy, just like testing. So as a planner, I'm going to jack up this lambda P here. People want to stay at home more, they stay at home more, that's a lockdown. People discount the future, beta, this depends on your age because there's a natural death probability. So the old die faster regardless of whether we have COVID or not. And then we have wages. So the young have to work. So remember this N up here. So the young has to work. The time that they work is N. The wage rate per unit of time is W. So WN is earnings. The old, they don't have to work. So they just got this W bar that just falls out of the sky for them, that's the retirement income or something. And their budget constraint, everyone's budget constraint, is consumption. Remember, food that you eat at home, plus this X, the beers that you buy at the bar, equals your income. Okay. As I said, for now, for today, the income here, the work here has to be done outside. If you don't go outside to work, you don't make any money, but you also have results that you can work from home at a penalty, according to the data. The qualitative results are very similar to the ones I'm going to show you today, but stay tuned, read the next version of the paper, and you'll see what happens when we get teleworking going on. Now, so this is what the guys do, right? So what would I do if there's no COVID out there, right? All of these lambda J's here would go down, and I would spend some time, at home, watching Netflix, sometime at the bar, sometime working outside. But when Netflix comes along, all of this time that I spend outside is risky. And it's risky because I can catch the disease. And catching the disease is bad because I can die. And if I die, I lose this B here that, it's the bliss of living. So how do I catch the disease? Well, I catch the disease if I spend time outside, okay? So the more time I spend outside, the more likely it is that I catch the disease. So this little pi here is the probability that I get infected with COVID. This big pi here is just like the aggregate infectiousness of the world outside. So if the big pi is high, the more time I spend outside, each extra unit of time that I spend outside increases the probability that I catch COVID. Now, how could I possibly be unsure? Remember, some of these guys are unsure whether they have COVID or not, or the common cold, right? I start sneezing. Is it COVID? Is it a common cold? Well, you might catch a common cold. Okay, so the more time you spend outside, you might catch a common cold. Okay. Okay. Now there is this guy here, this aggregate infectiousness. Why is the world out there risky? Well, the world out there is risky because there are infected people running around. So the riskiness of the world is determined by the amount of sick people outside and how much time these sick people spend outside. Okay, so as you aggregate all of these things, the more people are sick and spending time outside, the worse the world is out there. Okay, this is pi hat. In order to get this pi here, we need to have some continuous time aggregation. This is a technical detail, elegant, nonetheless, but it's a technical thing because with linear stuff like this, you can end up with probabilities higher than 1, and that doesn't make sense. Why would the probability be higher than 1? Because this here would count things like you get infected twice, which is ridiculous, right? If you get infected once, it doesn't matter whether COVID is in your lungs twice. So this aggregation here takes care of that. All right, then we have some Bellman equations that I'm going to skip. I hope it's clear what's going on. If not, do ask questions. Then to aggregate this, since we are in a macro session, to aggregate this stuff, output GDP in the economy is going to be the sum of what everyone produces, so the sum of wages. Then you have laws of motions that, I am healthy now, I may become a fever guy, unsure whether I have COVID or a common cold. Then I might end up sick, I might end up in the hospital, dead, etc. We have all of these laws of motions in the appendix of the paper. Okay, and the equilibrium, rational expectations. So this is important because this means the following. It means that as soon as COVID pops up in the economy, the agents know the entire path of the disease. Okay, they know that 2 months from now, how infectiousness is the world out there, et cetera, et cetera. Okay, so that's what rational expectation means. That's our assumption. All right, so how age matters, right? So the big thing of this paper here is that we have like these two different groups, the young guys and the old guys. How are they different? How does it matter? So the first thing that I mentioned already is that the old don't work. So they naturally spend more time at home. So even when we go, even in a world without COVID, a steady state, the old spend less time outside because they don't have to work. This is going to be important in some of the results because since they spend more time at home, they are going to contribute less to the spread of the disease. Okay, this is important for some of the results you got. The other thing is that they have a higher probability of becoming critically ill. So they have a higher probability of ending up in the ICU in the hospital. And once at the ICU, they have a higher chance of dying. So COVID is more dangerous for older guys, okay? They also have a higher chance of dying from natural causes, but actually that doesn't play a big role quantitatively. All right, so let's put numbers into this model. So remember that I was telling you about how the disease spreads, right? There's a key parameter here that we call pi 0, which tells you, you know, if you spend 1 unit of time outside and someone sick spends 1 unit of time outside, how fast does this thing spread? Okay, so we are going to target an R0 of 2.5. For those who don't know what the R0 is, and this is explained in newspapers a lot, but wrongly. So what R0 means is the following. Imagine a world in which everyone is healthy and no one has ever been exposed to the coronavirus, to the new coronavirus. And then imagine that I take one sick person and then I throw this person into this world full of susceptible people. How many susceptible people do I expect that infected guy to pass the virus to? That's the R0. Now, think about the following. In this world that I just described, everyone is healthy except one guy. So it's a measure 0 guy. So because it's so unlikely that this guy is going to find me, I'm not going to change my behavior, right? It's a measure 0 event. I'm not going to change my behavior. So this R0 is something that is computed under the assumption of no behavioral change. This is important because a lot of epidemiological models, they do assume that people don't change their behavior. And I'm going to show you some graphs that assumption leads to really weird results. Okay. So anyway, I'm going to skip the model fit. You know, the model fit is good, and we target some known. We match some non-targeted statistics as well. Let me go to some results. So here's the no disease case. Okay, so no one dies of the disease, no one's immune to the disease. And here's our benchmark, okay, that I just described to you. What happens here? Oh, one thing that I forgot, we assume that after 1.5 years, a vaccine comes along and the world is good again. So in the benchmark here, there's no policy whatsoever. The only thing that happens is that people change their behavior in response to the pandemic. So what we find is that about 4 of every 1,000 people die, okay, so 0.4%. And in the end, about 55% of people are immune in the long run. So this is herd immunity. Because people take care of themselves, they spend more time at home, they socially distance. You can see this right down here. People spend more time at home, both young and old, relative to a world with no disease. But you can also see that the old people protect themselves more than the young. So because of this extra protection, then more time that you spend at home, you spend less time working. If you spend less time working, GDP goes down. How much? You can compare this with this, 6%. So in the first year, you get a 6% recession only because without any policy, but only because people take care of themselves. Now, what if they didn't? What if we ran a model, take a look at up here, an epidemiological model like most epidemiologists, like all epidemiologists do, and people don't change their behavior? What would happen? Well, a lot more people would die. Okay, instead of 4 out of 1,000, we'll get 8 out of 1,000. A lot more people would get sick. Herd immunity would be much, much, much higher, okay, to get this disease in control. Okay, so behavior matters, and it matters a lot, okay, especially among the old. 3% of the old would die without any precautions, but less than 1% dies in the end. Now, let me talk about policy. So I'm going to skip the, remember that I told you there's this intricate age externality between young and old. I'm going to skip that. I'm going to skip this too. We have some beautiful graphs. And I'm going to skip this. So let me talk about policy experiments. So one policy is a lockdown. So a shelter at home order. So let's talk about this one first. Here I have a bunch of mild lockdowns. Okay, so you can see that's mild up here. What this means, what this soup of letters means, is that I ask people to spend 25% more time at home. I ask all people to do that, as opposed to only the young, for 4 weeks. So this is a lockdown, it's a mild lockdown that everyone is subject to for 1 month. Okay, what happens? Not much. Okay, the numbers are very similar. The interesting thing is that if you do a mild lockdown for everybody or the young only, it can actually backfire. And death rates go up. Why does that happen? Well, think about this one, which is more stark. If I lock down the young, I decrease their death rates, but I increase the death rates among the old. Why does that happen? It happens because as I lock down the young, the disease lasts longer now to disappear. As the disease lasts longer, the old people that are more subject to it have a higher chance of catching it throughout the entire path of the disease. They end up catching it more and dying in higher numbers. If you do a strong shelter-at-home policy, so a strong lockdown, what happens is that you mostly delay the disease unless the lockdown is really strong and lasts a long time. So 35 weeks is like 8 months. It's almost a year of a very strong lockdown. You can see that GDP, for instance, collapses. There will be a 40% recession, so something completely out of this world. Okay, so this would decrease the amount of deaths. Okay, because after a year and a half, remember, a vaccine comes along. Okay, now, and this is very much work in progress. I think I only have a few minutes left, which is the optimal lockdown policy. So these are weeks in the horizontal axis, and if this line goes up, it means that the planner, Pareto, wants to lock people down. So what this optimal lockdown policy looks like is that, you lock people up a little bit, then you don't lock them up for a while, and then you lock them up again. Okay, I'll show you what that means. An interesting thing, an amazing thing is the following. Because I have two groups, I could try to design a policy that is age specific. If I do that, I get the exact same thing. Okay, so what does that mean? Why does the planner want to treat old and young similarly? It's not exactly similarly, but this is the graph. So take a look here at the bottom right. So the dashed line is the benchmark, and the solid line is the optimal policy. Red is old. So you can see that the benchmark, whatever the old are doing, is exactly what Pareto wants them to do. Pareto doesn't change what the old are doing, but Pareto does change what the young are doing, which is really counterintuitive because the young are the ones that work. When Pareto tells these guys to spend more time at home, GDP goes down. You can see here in the bottom left corner. So GDP, the first recession here is endogenous because people want to stay at home. The second recession here is Pareto, okay? So Pareto tells the young to stay at home more until the vaccine comes along. Why does Pareto want to do that? Pareto wants to do that because the young is the group that is the bigger group. They are the ones that really carry the disease, especially because they spend more time outside. So Pareto tells them, you know, stay at home more, and that only starts after 6 months or so, 5 months. Why? Because this is when these guys start to, you know, slack a bit. So Pareto tells them to stay at home until the vaccine comes along. Now, as the young stay at home, then the world is going to look better outside. It's going to look safer outside. And then the old people would like to spend less time at home. But then Pareto tells them, no, I want you to do exactly what you were doing before. Okay. So that's it for optimal policy. I think I'm out of time. Let me just tell you that, you know, we have, by the way, this optimal lockdown policy improves the welfare of everybody. Obviously, it's optimal policy. And that translates to 20% fewer deaths. We also do other policies like testing. So if you test 50% of the fever guys, of the unsure guys, and quarantine them, then you get 30% less death. If you test everybody and don't quarantine anybody, why would that help you? Because people are altruistic. If you know, in our model, if you know that you are sick, you stay at home more. So you get this about the same, 30% less death. If you test everybody who is unsure and you quarantine everybody, you stop the disease. So essentially testing, contact tracing, testing, isolating people is remarkably effective, okay? So I think I'm out of time, so I'll stop here. There's tons of other things we do, but I don't have time to go over them. Thanks a lot.
Any question to Cesar about?
Cesar, could you please explain? I mean, I think I kind of didn't follow how in the utility functions, if there is any role for example, attitudes of agents towards risk, you know, how that would change if you kind of parameterize the model using these, you know, income attitudes toward risks. How would that play out if you thought about it? And if, I don't know, if you calibrate it using different parameters, I'm thinking about, I don't know, younger, riskier than older, or I don't know, Brazilians more risky than Europeans, and if how that would change the
so
results.
I don't think you'll get any changes if, for instance, instead of log, you use like a higher coefficient of relative risk aversion, because there's not a whole lot going on here. I think the parameters that really matter for the intertemporal choice is the discount factor and this B here. Okay, this B is the utility that you get from just being alive. So I didn't tell you how we calibrate this. We're actually changing how we calibrate this, but what we're going to do next, and what people usually do, is calibrate this B to match the value of the statistical life. The value of the statistical life, for those who don't know, is I ask you, you know, how much are you willing to pay for me to decrease the probability that you die in the next month by 1/10,000? Okay, then you tell me, you know, it's $1,000. So if it's $1,000, then, you know, for 1/10,000, if I get 10,000 out of you, I save one life. Okay, so that's the value of the statistical life. So these numbers usually calibrated to something between $8 and $10 million. Okay, it's not how much you are willing to pay, it's how much a collective of people like you are willing to pay. So the $8 to $10 million that I was telling you about is the US. So if you change this calibration for B here, maybe the value of the statistical life is higher in the US than it is in Brazil, then you get people to behave quite differently. and then you get a different kick out of behavioral changes. Okay, so I think these guys and this and beta, I mean, this is almost isomorphic. Okay, so how you calibrate this guy here, it's really going to drive how you change your behavior, your intertemporal behavior, right? Because that's what matters. If you go outside now, you might get sick tomorrow. Okay, maybe that answers your question.
Yeah,
By the way,
definitely.
let me do like some propaganda. There's another session tomorrow that me and my co-authors have on the prize session, that we actually take this model to Brazil and talk about people that live in slums, in favelas, and people that don't. So you might end up with people valuing life differently. So we have a calibration for Brazil in a slightly different model.
Cesar?
Yeah.
We seem to have a vaccine on site.
Yes.
What would your model suggest? Serious lockdown or?
So we do have a vaccine here. So I don't know if you can tell from these graphs, but there is a kink just before week 80. Right? So there's a kink right here. The reason why there's this kink is because there's a vaccine. Okay. So we played with how early or how late the vaccine comes, okay, and how people change that. If in a world that people don't change their behavior, that's the dashed world here, it doesn't matter. As you take a look at this, essentially, you know, the disease is gone within 6 months. Okay, so unless the vaccine comes in 3 months, which we already saw didn't happen, you know, but the behavior changes. Okay, so if you bring this vaccine earlier, people might be a little bit less fatalistic and spend more time at home to wait for that vaccine. Okay, the policy, the optimal policy, works in this way, right? This guy here says, look, you guys are starting to slack here and spend very little time at home. Pareto says, no, I want you to stay more time at home. And Pareto starts to slacking because Pareto knows the vaccine is coming along. So if the vaccine comes along later, this guy here might go a little bit up or down. But this shape here of the optimal policy is exactly driven by the fact that the vaccine is coming here.
Okay. So, thank you. Let's follow with.
Okay, thanks a lot.
How do I choose full screen?
If you go to view and full screen, no?
Oh, yeah. Can you see it?
Yes.
Okay, so to close the session, I will present the paper on rainfall and structural transformation in Sub-Saharan Africa. Okay, so structural transformation refers to the reallocation of economic activity across broad sectors of the economy. And here in this paper, we will refer to the reallocation of labor from agriculture towards non-agricultural sector. So it's labor moving out of the agricultural sector. We'll discuss the case of Sub-Saharan Africa for the period that goes from 1970 to 2014. And the focus of the paper will be in quantifying the impact of rainfall anomalies, of droughts, their reallocation of labor out of the agriculture, and also its impact on aggregate productivity. Okay, so it's going to be a cross-country analysis for 15 countries. And throughout the presentation, I will be referring to this term rainfall anomaly that refers to the deviation of rainfall from its long-run average divided by the standard deviation. So it's just a measure of rainfall deviation with respect to past survey. Okay, so before anything, a few facts on Sub-Saharan Africa. In Sub-Saharan Africa, a large share of workers are located in the agricultural sector. In 1970, on average, 73% of the workers were in agriculture. In 2014, this share was still large, and on average, 53% of the workers were in agriculture, so more than half of the workers still works in the agricultural sector. About 19-70% of farming is said to be rain-fed. It means that the farming practices relies only on rain for water. We don't see widespread use of irrigation systems, what making the farming practices very dependent on climate conditions. Okay? And we do observe large droughts in the 80s and 90s. That is also a period of low growth of GDP per capita in Sub-Saharan Africa. Okay, so there is a strong correlation between rainfall anomaly and GDP per capita growth of about 0.73. Okay, so what do I do in this paper? This paper builds on this Schultz food problem idea. This is an idea that goes back to the 1950s and is like, until countries can produce a sufficient amount of food, of agricultural goods, labor is trapped in agriculture. That is to say that the main mechanism that pushes workers out of the agricultural sector, it is the growth on agricultural productivity. Okay, so the mechanism of the paper is like, it is, drought is a negative productivity on the agricultural sector, which postpones labor out of the which postpones the reallocation of labor out of the agricultural sector. It makes it more slowly. And because the non-agricultural sector has much higher productivity, the final effect on aggregate productivity is quite high. Okay, so putting two numbers, the non-agricultural sector has productivity of on average 10 to 12 times higher than agriculture in the 70s and 90s, and more recently is like 6 times. Okay, so it's quite larger. Okay, so there are two impacts of droughts on aggregate productivity. One is the direct impact on the productivity, on labor productivity in the agricultural sector. And the second impact is this is lower reallocation of labor out of agriculture towards the non-agricultural sector. Okay, so a big chunk of this paper is about endogenizing this reallocation across sectors. Okay, so this paper, I quantify the impact of rainfall anomaly in the structural transformation of Sub-Saharan Africa, that is in the reallocation of labor across sectors and on aggregate productivity, and I will do it by the means of a counterfactual. I'm gonna ask, how would the economy have behaved if there were no droughts? So the steps, I follow 3 steps to do so. I use a production function to measure the impacts of precipitation, of rainfall on agricultural productivity. And then I use this estimated production function to construct the counterfactual. I use the production function to ask, how would the labor productivity in agriculture have behaved if we haven't observed the drought? Okay, if there was no rainfall anomaly. And then using a general equilibrium framework, I feed the model with the counterfactual productivity and then compare the results with the data. I need a model because the allocation of labor across agriculture and non-agricultural sector is endogenous, okay? So the results, what I find large impacts in countries of Western Africa. Here it's Senegal, Burkina Faso, Ghana, Cameroon, and Nigeria, and also in Ethiopia, okay? So on average, the share of labor in agriculture would be 1.5% lower. That is, if there was no rainfall anomaly, we would have a lower share of workers in agriculture, the reallocation would be faster. Aggregate productivity would be on average 8.3% higher. And the reallocation margin across sectors accounts on average for 47% of the impact. What is driving this margin is because the difference in productivity is quite high. Okay, so for the case of Burkina Faso faced negative rainfall anomalies in every year between 1970 and 2014. Okay, so it has suffered with persistent drought. So on average, the labor share in agriculture would be 1.9% lower. In 2014 would be 4.5%. Aggregate productivity should be 22% higher, and the consumption index in 2014 would be about 4.4% higher. Okay, so I started with this graph with the average rainfall anomaly for Sub-Saharan Africa. The World Bank provides data on precipitation at a country level starting in 1901. So what I do, I compute the rainfall anomaly for each country. I take out the long run trend, and then I average out among them. Okay, so this is a simple average of the anomaly between the countries. We do observe that until the 1950s, it was relatively small variations. The 50s and 60s, we see a lot of rain. And then the 80s and 90s, it's a period of droughts because the rainfall anomaly is negative. The 80s and 90s is also a period of slow GDP per capita growth in Sub-Saharan Africa, and then it returns around the 2000s. As usual, there is a lot of heterogeneity among the countries. Here I plot the average of rainfall anomaly for the period that goes from 1970 to 2014. Okay, we do observe that the countries from Western Africa suffer with more serious droughts. Other countries in which we do also observe droughts on average is Ethiopia, Malawi, and Mozambique, even though Malawi and Mozambique is relatively small. And for the other countries, we actually see a positive anomaly. Okay, so there was on average quite a lot of rain: Rwanda, Uganda, Kenya, Tanzania, Namibia, South Africa, and Lesotho. In the particular case of Senegal and Burkina Faso, we actually observe droughts in every year between 1970 and 2014. Okay, so those were periods with negative anomaly, even though for some years it was kind of small. So I use the production specification from Dow Jones and Oakland to measure the impact of rainfall on productivity. So rainfall impacts, so output is linear in labor, and rainfall impacts the level of productivity with parameter gamma, and it also impacts the growth of productivity with parameter phi, and the growth of labor productivity also depends on an exogenous term, epsilon z. Okay, so this production function, this production specification, it gives me a function which the growth of labor productivity in agriculture depends on the variation of the anomaly, on the level, and on the exogenous term. Okay, so I use equation 4 as reference to estimate the impact of rainfall on labor productivity growth. Okay, that I do use a Standard Oil-less cross-country fixed effect estimation. In the first column, I show the estimation of equation 5 without any fixed effect, and then we don't see any impact of rainfall on labor productivity growth. Once I add fixed effects, then rainfall starts to have an impact on productivity growth. And then I consider the third specification, which I add an interaction term between rainfall and negative average. Negative average is a dummy that takes the value of 1 if we do observe a negative average for the period between 1970 and 2014, or 0 otherwise. Okay, so it's equal to 1 if in the map it was red, dark red, and orange, and 0 if it was blue. In this case, only these terms is now significant, while the coefficient associated with rain, it's not significant anymore. So that indicates that rainfall matters in the countries in which we observed persistent droughts. Okay, it didn't matter for the others, so it indicates a potential asymmetry impact of rainfall on agricultural productivity. So droughts would represent a negative shock, while too much rain would not represent a positive shock. Okay, so using these results, I use these results to calibrate the production function. I set gamma equals 0 and phi equals 0.02. So that implies that if the anomaly is equal to 1 standard deviation, okay, capital T equals -1, it reduces the growth of labor productivity in 2%. Okay, and then once I have those parameters, so having the parameter phi and also having the anomaly, I can compute the exogenous term so that it reproduces labor productivity in agriculture exactly. That's by definition of the exogenous term. Then to construct the counterfactor, I use this just calculated exogenous term, and I set the anomaly equals 0, and then I can get the counterfactor. Okay, so here I show the example for Burkina Faso, in which the solid line represents the observed labor productivity growth, and then we do observe the counterfactor being higher than observed. Okay, the counterfactor is kind of higher than the data because, as we can see in the panel B, Burkina Faso suffered with negative rainfall anomaly in every period. Okay, every period between 1970 and 2014 were periods with negative anomaly. So it was persistent negative shocks on labor productivity growth that compose with time. After all, phi impacts the growth rates. Okay, that is leading to large impacts. Burkina Faso is the one with the largest one together with Senegal, as expected because of the persistent droughts. Okay, so once I have the observed labor productivity and also construct the counterfactor, then I make the standard approach to a macro model that is simulate with the counterfactor, compare the results. So the model is quite simple. It has two sectors of production, agriculture and non-agriculture, and free mobility of labor across sectors. The production function, it is just mentioned, it is linear in labor. Household supplies labor inelastically, and it has non-homothetic utility over agriculture and non-agricultural goods. Okay, so non-homotheticity of preferences implies changes in the consumption patterns associated with increased income. So the idea is that when we're poor, we consume a lot of agricultural goods, we spend a lot on food, and then as we get richer, we start to consume more of other goods, of manufacturing and services. Okay, so it changes the consumption share of agriculture declines with increasing income. Okay, so that's the idea of the non-homothetic utility, and I'm assuming a competitive economy. Okay, so from the production side, as mentioned, production is linear and the firm takes price as given to maximize profits. From the household side, I'm using as preference the implicit non-homothetic CES. It's a preference from the 70s from Hanok, and that it has been introduced in the structural transformation literature by Comín, Lascano, and Messieri more recently. So the household has utility over aggregate consumption C, and C is implicitly defined with this CES aggregator, okay, where omega I is a constant weight parameter of good I, the sigma is the elasticity of substitution, and the epsilon I is a measure of income elasticity of good I, okay? If epsilon I equals 1 for every I, so for every good it is equal to 1, we would just get the usual CES aggregator. So this is just a more general case of the CES. Okay, so as we can see, using the CES aggregator, sigma is the elasticity of substitution, and the relative demand between the goods with respect to the aggregate consumption, it is constant and is given by the difference between epsilon I and epsilon J. So if epsilon M is bigger than epsilon A, it means that as aggregate consumption increases, the demand for non-agricultural goods increases more than the demand for agriculture. Okay, so just to close, competitive equilibrium is a standard. Okay, so now going to the preference parameters on how I calibrate the model and simulate it. I normalize productivity to 1 in 1970 at both sectors, and I also normalize labor in 1970 equals to 1, and then I choose the omega parameter that matches the labor share of country in 1970. Okay, so I'm gonna calibrate gamma so that the model is equal to the data in 1970. Okay, and because of all the normalizations, gamma ij is equal to the labor share in sector I in 1970. So the labor share in agriculture in Burkina Faso, that's how much it will be the gamma parameter. Also, because only the difference between the epsilons impacts the relative allocation, I said epsilon A equals to 1. And then I choose sigma and epsilon m to minimize the square difference between model and data. Okay, so I'm choosing the same sigma and epsilon m for all the countries. And then the estimation indicates me that the elasticity of substitution sigma is equal to 0.83. That is, the goods are complements. And the income elasticity parameter epsilon m equals 3.2, what indicates that non-agricultural goods is a luxury good, agriculture is a necessity. So as income grows, the consumption for non-agricultural goods grows more than for agriculture. There is a decline in the consumption share of agricultural goods. Okay, so the simulation is standard. Given the parameter values, I feed the model with the observed productivities, and then I compare the results of the model with the data. The model is calibrated to feed the data in 1970. So to evaluate the feed of the model to the data, I compared the labor share allocation in 2014 of the data with the model. So in the x-axis, I have the data in 2014. In the y-axis, I have the model, okay? And the closer the model is to the 45-degree line, the better is the feed. So for example, in Tanzania and Lesotho, the allocation of the model is pretty close to the data in 2014, okay? The average mean average error of the labor share in agriculture with respect to the data is 5.8%. Okay, and the same for the aggregate labor productivity. Okay, so anyway, so the model has a decent fit, but it's not exactly perfect. I'm assuming free mobility of labor across the sectors. So I'm gonna add in the model these wedge distortions that are supposed to be frictions that restricts the reallocation of labor between the sectors. Okay, so I'm gonna compute this distortion so that the labor share in the model equals the data. So all I'm gonna do is to add these labor demand distortions in both sectors. Okay, and they're gonna be calculated such that the allocation of the model will be exactly the same as the data. Okay, so here I showed the example for Burkina Faso. In Burkina Faso, we do observe that labor productivity in agriculture persistently increased. So the model will tell me that the labor share in agriculture should keep declining. But then when we do look at the data, the labor share in agriculture is roughly constant till 2000, and then after 2000, it declines quite fast. Okay, so from the lens of the model, it is as if there was an increasing binding constraint until 2000, and after that, this distortion was disappearing. In the particular case of Burkina Faso has a land policy in which essentially all land in the country is owned by the government, and the government determines it used to determine its allocation. And then in 2000, they start to increase property rights. Okay, so there was an increase in, they start to provide more property rights and increasing land tenure that led a lot of workers to move towards the non-agricultural sector.
Marcos, the right panel, is this tau or 1 plus tau?
1 plus tau.
So isn't it weird that it goes below 1?
It's the ratio of the two. So it's the 1 plus tau of manufacturing relative to agriculture. Okay, so it would be as if there was a tax on manufacturing on non-agricultural sector restricting people to go. Yeah, it's the ratio. Okay, so now to compute the impact of rainfall anomaly. Okay, so by construct, I simulate the model with agricultural productivity and non-agricultural and those wedge distortions. It replicates the economy exactly. So to measure the impact of rainfall anomaly, I simulate the economy with the counterfactor, with non-agricultural productivity, and with the wedges, and then I compare the results. Okay, so for Burkina Faso, using the counterfactor productivity, labor share would be below than the data through the entire period. Okay, being 2014 should be about 4% lower than observed. And then in the right panel, I show the effect on aggregate labor productivities, in which a counterfactor should be higher, and also we should be observing more labor in the non-agricultural sector, whose productivity is much higher. So the total effect is given by the difference between the green dashed line and the blue, the data. But this is the total effect, where there is the direct effect and also the reallocation margin. So to disentangle the two, I recompute aggregate productivity with the counterfactual agricultural productivity, but with the data, with the blue line, with the label showing the data. And then I get this orange triangle line. So the distance between the orange and the blue gives me the direct effect, while the difference between the green line and the orange line gives me the reallocation margin. Okay, so this is the result for Burkina Faso. So now the results for the other countries. I made the counterfactual exercises only for the countries in which there was a negative average rainfall anomaly because of the results of the regressions. So for example, if I compute the mean average of labor shares for the countries, I get that on average it should be 1.4% lower than observed. If I use it only for 2014, the number is higher because the drought effects accumulates through time. Okay. The consumption index should be about 4.4% high in Burkina Faso, for the countries around 1%. Okay, and in the case of Burkina Faso, we also see that aggregate labor productivity would be about 22% higher than observed, and the reallocation margin would account for 47% of the total impacts. Okay, so just to call attention that these numbers reflect all the cumulative effects. Okay. And then the conclusions of the paper, I find that persistent negative rainfall anomalies have had large impacts in Sub-Saharan Africa for many countries, and that the share of labor should be on average 1.4% lower, and a lot of the impacts of the reallocation margin comes from large differences in agricultural productivity. Okay, I stop here.
Can I ask one question, Marcos?
Sure.
Basically your model is sort of closed economy model, right?
Yes.
So do these economies behave like closed economies, or do they have like, is it like a factor mobility is important between these economies, for example, labor mobility? I don't know, how is the exchange rate regime, how the exchange rate, for example, would buffer some of these shocks, you know, some of these rainfall shocks. So it's more like a curiosity rather than.
Okay. So first, I'm focusing here a lot on the long run effects. So I'm focusing on persistent droughts. So I'm not looking much on buffers. One question that I think it's related with is like, people ask a lot, for example, one solution could be food trade, right? You could satisfy basic needs of consumption trading food. After all, the impacts of droughts is coming through lower productivity in the agricultural sector that could end up buffering all the impacts of droughts. In the case of Sub-Saharan Africa, we see very low food trade. Okay, like it's more than 90% of the food consumption is produced inside the country. So there is almost no food trade there. About the exchange rate, I cannot say much.
Yeah, I'm thinking of, because when you mention sectoral differences, right? There is the famous Balassa-Samuelson effect, which happens between non-tradables and tradables, which could be pretty much your agriculture and non-agriculture sectors. However, I mean, it'll be sort of a weird effect in the case you're mentioning, because consumption is subsistence, right? And And as I said, I don't know how is the setup of these economies, how open they are to each other, at least, you know, regionally speaking. So I don't know if that's relevant or not, but it's
for food trade, they are fairly close. Like, because the common policy suggestion is open food trade. Because if you do have a negative shock on food trade, and that's a necessity good, put workers into non-agricultural, they are way more productive, buy food on the international market, and buffer it a lot. But by some reason, we don't see that. And here it's more of a, not exactly a normative paper, you know, but it's trying to measure the total impacts of droughts, including the reallocation margin. So there is a lot of work trying to measure the direct impact of droughts on labor productivity, but there isn't much endogenizing the reallocation between sectors.
Thank you.
Marcos, 2 comments, not necessarily questions. One is just that I was in the CPR meeting the other day, and Nathan Nunn was presenting something on climate change and conflict. So he used like rainfall data. I don't know if you saw that. Nomadic tribes.
No, but
That's something that might be interesting with Nathan Nunn, what is working on stuff like this. I know that rainfall, a lot of people work on rainfall, so you probably know a lot, but one more. The other comment is more like how to frame the results. So like the results are like, you know, labor productivity, GDP goes up by that much. If you could maybe do the following, like imagine like you take another country, maybe even a country that was like positively affected, like South Africa or whatever, but like, which is richer than these other countries. And then what if you said, you know, this is what we would expect, this is what happens to like convergence or lack of convergence across these countries. And this persistent drought thing moved by that much. Something, a number like, you know, maybe, you know, Burkina Faso would have closed the gap 10% more without these things.
Yep.
So I think it would be easy to do, and maybe it would be like,
okay, no. Fair enough. Any other questions? No. So I think we passed from the time, right? So we finished the session here. Thanks for all the speakers, and we end up here.
Thank you, Marcos. Thank you, Cesar. Thank you all.
thank you.
Thank you, Eduardo.
All right, thank you all.
Right.
Marcos, thank you, Cesar.